research lab, where one of the most important tools we use is called the Ultrasound Transducer, which is right here. This transducer is used to image objects such as organs, tissues, and even blood flow inside of the human body. The transducer is made out of an array of crystals that receive electrical impulses from this machine right here. And what happens is that when these crystals are met by this voltage, they expand and contract rapidly, so they produce a vibration which sends out a pressure wave or a sound wave from the transducer up towards the hydrophone up here. Different transducers have different shaped waves. Some of them start as a circle and then they converge into a small point and then they diverge again. Others focus as a plane, like a rectangular plane. There are two qualities of transducers that exist as a trade-off. These two are resolution and depth. So as you get clearer images, you can't go that deep into the skin. Trade-off between two qualities of transducer. These two are resolution and depth. So the clearer the images, the less deep you can image under the skin. For clinical applications, these sound waves can only travel through water. So when the sound waves hit the air, they reflect back and they get a really dark screen. But better images are produced when the sound waves bounce off an object that has a lot of contrast between the surrounding tissue or water or blood. When sound waves bounce off of an object and head back towards the transducer, they are in the form of a pressure wave. So when pressure hits the crystals in the transducer, an electrical signal is recorded in the machine right here called the oscilloscope. The focal length of the transducer can be found by moving around this motorized stage. So this gives us, it's a pulse echo, so it shows us where the strongest signal is received. So when we move around the transducer using the motor, you can see that the signal increases, decreases depending on what's being reflected. So sometimes the signal will increase, which means we are where we're supposed to be, but other times it'll decrease, meaning that we're way off. So to center it, we had to find the largest signal, basically. So here we would be centered, right at the center of the hydrophone, which is just basically a receiver of sound. This is where in here is basically we're doing research on stuff before it actually goes to be used for clinical applications.